Good afternoon, everybody. I am Antonio Musarra, and I am the senior software architect in SMC. In this era of plentiful, standardized API and explosion of powerful JavaScript framework and library like Angular, React, and Vue for web development and building front-end experience, it can be tempting to think that a full-blown digital experience platform such as Liferay may not be needed. After all, it's relatively easy to build your own front-end experience on top of headless and microservices backend API. Why do you need all the additional bells and whistles? In this presentation, we will see how the Liferay platform within its own microservices architecture can be exploited to its advantage and give value to its solution. Well, let's see what will be the topics that I will cover. We will see a small introduction to the world of microservices. Some of you we already know what it is. We will see Liferay as microservices platform. We will see how the DXP platform can be used to our advantage. We will see how headless CMS favors context of microservices. Overview on microservices. The architectural approach, an already now approach from SOA architecture to microservices. The advantages of microservices architecture is advantages of the microservices architecture. Well, microservices are an architectural approach to building application. What distinguished architecture based on microservices from traditional monolithic approach is subdivision of the app into basic functions. Each function called a service can be compiled and implemented independently. Individual services may or may not work without comprising other. In this diagram, we can see the difference between the monolithic approach and the microservices approach. Each single function is represented by a specific microservice that insists on its own dataset. Therefore, a microservice is a basic function of an application which runs independently of the other services. However, the architecture based on microservices not only involves the low coupling between the basic functions of an app, but proposes a restructuring of the development teams and the communication framework between the services. This approach offers the possibility to manage unavoidable critical issues, supports dynamics scalability, and facilitates the integration of new features. To deploy microservices and take advantage of this approach, you need to adapt the basic element of a service-oriented architecture, or SOA. An already now approach. Dividing an app in two basic functions and avoiding the pitfall of the monolithic approach may seem familiar concept because the architectural style of the microservices is similar to that of the SOA architecture. A well-established software design style. In the early days of application development, having a minimal change to an existing app required a complete update and a quality assurance cycle of its own, which risk slowing down the work of various secondary teams. This approach is often referred to as monolithic because the whole app source code was compiled in a single deployment unit. For example, war or ER artifact. If update to part of the app caused errors, it was necessary to disconnect everything, step back, and correct. This approach is still applicable to small applications, but growing companies cannot afford downtime. And here comes the SOA architecture, in which the apps are structured in reusable services that communicate with each other via enterprise service bus or SB. In the SOA architecture, the individual services focus on the specific business process and flow and follow a communication protocol, including SOAP, ActiveMQ, or Apache Thrift, to be shared through the ESB. Overall, this suite of services integrated through an ESB constitute an application. In addition, this method allows you to compile, test, and modify multiple services simultaneously, freeing IT teams from a monolithic development cycle. However, since ESB represents a single point of failure for the whole system, it could pose an obstacle for the whole organization. Well, let's see the transitions from SOA to microservices architecture. Microservices can communicate with each other, generally in stateless mode, allowing you to build apps with greater fault tolerance and less dependent on a single ESB. They communicate through language-independent application programming interface, API, and these allow development teams to choose their own tools. Considering the evolution of SOA, microservices are not an absolute novelty, but lately they have become more attractive thanks to the advances in containerization technologies. Today, Linux container allow you to run multiple parts of an app independently on the same hardware with far greater control over individual component and life cycle. In combination with the API and the DevOps teams, containerized microservices form the basis of cloud-native application. The advantage of microservice architecture. Based on distributed architecture, microservices allow for more efficient development and routine. The ability to develop multiple microservices simultaneously allow multiple developers to work on the same app simultaneously, reducing development time. In this mind map, show you the advantages of the microservices architecture, which are faster time to market, superior scalability, resilience, and greater openness, accessibility, simplicity of deployment. Okay, this advanced of the microservice architecture. If you decide to switch to an architecture based on microservices, it is essential to be able to change the culture of communication and collaboration between the teams, not just of the app. Changing corporate culture can be difficult, in part because each team follows its own deployment cadence and is responsible for a single services for a specific group of customers. While not a problem strictly related to developers, overcoming it becomes essential for the success of the architecture based on microservices. Partitioning an application into independent services also means that are multiple moving parts to maintain. This is clearly quite evident in this type of system, but there are consequently new factors to consider. In this mind map, show you disadvantages of the microservices architecture, which are more complex orchestration, communication between services, maintain high availability, test, and consistency of data. Well, next point is Liferay as microservices platform. The platform OSGI microservices deployed to container platform. Next one. OSGI as a core technology of Liferay. Defined best practice can be helpful. Transparent platform, valuable for developers. Opportunity for iterative modularization. Well, Martin Fowler has wrote, you shouldn't start with a microservices architecture. Instead, begin with monolith, keep it modular, and split into microservices once the monolith becomes a problem. What are the key aspects of platform like Liferay that embraces modularity? Well, point one, allow independence of development, deploy, and evolution. Point two, combine together the components that already exist. Point three, reuse and facilitate the customization. Good. Peter Kreens wrote in his blog in 2010, what I am promoting is the idea of microservices. The concept of an OSGI services as a design primitive. Let's briefly see what OSGI microservices are. In OSGI, microservices have existed for even longer, a way to maintain loose coupling between modules, a dynamic representation of a changing physical environment. OSGI services are ultra lightweight microservices, just a call from one object to another. OSGI services are usually in process. An OSGI services is Java object. It's registered in OSGI service registry. The registration includes the service API. The diagram shows the process of registering services by bundle A and use of services by bundle B. OSGI services also have properties. These provide additional information. They can help clients when multiple services exist. They can also communicate other information. OSGI services are an excellent way to build microservices, easy way to publish and services, easy way to consume services. This diagram shows how a service defines additional properties and how it has a provider and consumer. Well, this table shows the relationship between microservice according to Fowler and OSGI microservices. As you can see, the different is running in its own process. I remember that the OSGI microservices are in VM process. Separate processes do come with a benefit: full isolation, easy scalability. All these translated into OSGI remote service. Good. Two OSGI specification for OSGI remote services: remote service transport, remote service admin, topology, and service discovery. And finally, let's see which are the best points of both worlds: independent deployment, iterative development, fault-tolerant but not full isolation, no network latency, reduced call stack, more freedom to choose technology stack, less demanding for operation, established monitoring and deployment strategies. Let's see how easy it is to deploy Liferay and our application in the form of containers. If you are building a microservice architecture, containers are the ideal deployment unit for any microservices. Liferay has long embraced and works constantly to support the technology of containers. Liferay has integrated the development environment with tools to facilitate the IT team for creating a Docker image. And this is enabling for a context of DevOps. Directly from Liferay workspace, we are able to create our Docker image that contains the Liferay platform and the additional modules that we have developed and that we want to release. Good. Liferay provides Docker images for Liferay Portal, Liferay DXP, Liferay Commerce, Liferay Portal Snapshot. You can pull Liferay Docker images from Docker Hub and manage them yourself. Liferay Workspace, however, provides an easy way to integrate Docker development into your existing development workflow with pre-configured Gradle tasks. Well, here you can see the official Docker image repository. Here you can see the Liferay repository on GitHub for building Docker image. On this repository, I made my small contribution. Well, here you can see how each configuration on the properties file can be applied via environment variable. Thanks to the support for containers, it is possible to deploy our Liferay application on container platform, such as Google Kubernetes Engine or Red Hat OpenShift container platform. For example, Marshall Calvo Valenzuela, consultant at Liferay, recently published on the Liferay blog the article deploying Liferay 7.3 Community Edition in Kubernetes. This article describes how to deploy Liferay in conjunction with a service stack on Kubernetes, NGIX as an ingress, MySQL as database, and Elasticsearch as engine search indexer, as well as how to manage Kubernetes from GUI dashboard. These images show the installation of a Liferay cluster on Red Hat OpenShift. Well, the next section is digital experience platform. Liferay is a DXP platform. What are the most common reasons for not using a DXP platform? Well, you can build your digital presence from scratch without a platform approach. This strategy will give you the most freedom, since you can create the ultimate customized solution to meet your needs. Digital experience platforms are monoliths, and it is not cool to use a monolith architecture in 2020. Besides, with a monolith, it is harder to take advantage of containerization. Think Docker and Kubernetes. A digital experience platform is a heavyweight compared to JavaScript front-end with RESTful microservices API. A digital experience platform is harder to scale up for internet scale application, and it is harder to handle traffic bursts. What are the reasons for using a DXP platform? A single unified platform that can be used to handle multiple use cases around which an enterprise can train its team. A whole view of out-of-the-box functionality, including content management, personalization, and targeting, security, collaboration, form, workflow, analysis, and optimizations, commerce, and more. Multiple deployment. It is highly unlikely your organization will be deploying just one page or having just one site. A digital experience platform offers a way to manage all your pages and sites from one page with a robust permissioning system to define rules and workflows. Better metrics. A digital experience often provides engagement metrics that help business understand which content is performing well and which isn't. So they can make informed decisions about what pages and messaging are resonating with customers. Collaboration is key to creating a modern digital experience. Business users in marketing and other departments need to empowered to modify content and messaging on the fly with minimal intervention from IT. A digital experience platform allows developers to create a preset content fragment that business users can reuse at will across site and pages. Headless and even decoupled capabilities for organization with robust front-end development teams that wish to create their own presentation layers. Well, let's take a few minutes to respond to opponent of the DXP platform. While the option to build your own digital platform and solution can look enticing to your engineering team, it is not to be taken lightly. Do you have the resource to build, maintain, and improve your platform for a year to come? It is true that a digital platform is a monolith from the distribution point of view, but Liferay is internally modular. I give you great news. You can run Liferay in container form. Yes, a digital platform is here compared to JavaScript front-end and RESTful microservice API. But it also comes with significant out-of-the-box functionality that can be used to create a personalized, collaborative experience for your users. Yes, a digital experience platform is harder to scale up for internet scale application and traffic burst compared to JavaScript front-end and microservices. However, digital experience platform scale just fine for 99% or higher of use cases, many with millions of users and over 100 million page hits a month. Well, the next section is headless CMS open to microservices. Well, what is a headless CMS? Headless CMS is a backend only content management system which works on as a content repository and gives access to this content via REST or GraphQL services. Liferay full reflects this definition. In traditional CMS, you have the following core subsystem: content creation and management, publication workflow, content delivery, analysis, and monitoring. Headless CMS focuses just on content creation and publication workflow. It is your application responsibility to get the content and display it in appropriate way based on your users' needs, devices they use, and channels they operate on. More flexibility and control. Liferay Foundation as a development platform continue to evolve with the additions of endless API for out-of-the-box services. Developers now have unparalleled flexibility to integrate Liferay into whole system, whether it's collecting data in Liferay or bringing Liferay into existing system. Compliant with Open API standard, Liferay API levels support the Open API specification, the most popular open source framework for RESTful API. GraphQL is also supported for easier development. Support for headless CMS and commerce. Liferay support API in all of our content and commerce features, allowing you to create a fluid front end for the entire customer journey. Nicely fit into microservices-based solutions. In this video, you can see how the headless API served the content to a different type of the device. Good. In this example, Liferay headless API and GraphQL API are used as data source for Gatsby. The latter will then be used to build the structure of the site or blog. Chris Mount on Liferay blog has published 2 articles dealing with this topic. In this example, Gatsby, the letter will then be used to build the structure of the site or blog.